Hi everyone, and welcome to my session, What is New with Azure Machine Learning. Thanks so much for joining me, and in this 45 minutes I'm going to show you everything that is new with Azure Machine Learning and how you can use Azure Machine Learning. So my name is Henk Boelman, Cloud Advocate at Microsoft, and I'm based in the Netherlands. I'm a white male with brown hair, wearing a shirt with a bit logo on it, and it is a dark blue color. So you can reach me on Twitter. You can find all the demos I'm going to show you today on my GitHub, and you can read more about everything I'm going to tell you on my blog and more about Azure Machine Learning. So in this session, what are we going to do? We're going to have a look at what Azure Machine Learning actually is and what you can do with it. Then we're going to train a PyTorch classification model. Then we're going to create a machine learning pipeline and deploy that to a managed endpoint. So this session will not have maybe 4 or 5 slides. The rest will all be demos, which you can just get off my GitHub and also do it at home. So first question, what is Azure Machine Learning anyway? So we call it Azure Machine Learning, that is short. You can also call it Azure Machine Learning Service. You can also call it Azure Machine Learning Studio. Those things are actually kind of the same thing if we talk about it. So what is it? It is a set of Azure Cloud Services that can be controlled using the Python SDK or the Azure CLI. And that set of cloud services and their SDKs enables us to do the whole machine learning lifecycle, from preparing data all the way to deploy and run them in production. But the cool thing is that we can use our own scripts and our own data. And we can work together on those machine learning projects. So that is all super cool. So these are already the slides. So let's go to machine learning to Azure Machine Learning Service. So here we are. Microsoft Azure Machine Learning Studio. So you get the studio by going in the portal, say create machine learning and Azure Machine Learning. It will spin up some resources for you. And then you can access those resources by going to ml.azure.com. Select your subscription, you select your, from your subscription, you select your workspace, and then you're here at the screen you're seeing now. So on the screen you're seeing now, we have a lot of different things we can do. So we will go from top to bottom over all the options. So first, this is our splash page. Here we can have some. Here we have some quick starts. Here we have some recent things I've trained, all my recent projects, and on the left we have notebooks. So we can actually create, compute, and run notebooks here in Azure Machine Learning. We have automated machine learning. We can do that in a graphical interface with a wizard, click, 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 and pick the best algorithm to solve my problem using my own data. We have designer. We saw that in the previous session. So if you have more interest in that, go and watch the previous session. But this designer enables you to just drag and drop your tasks or components in Azure Machine Learning, connect them, and actually create your machine learning model, solve your problem without almost any code. Under data sets, we keep track of all our data sets. So the data is actually located on one of your data stores. And from the data on your data stores, you can create data sets. And here you can also version your data sets. So what we are going to use today is my Lego V1 Simpsons data set. So it is a Simpsons data set with Lego figures. So here we see in which version we currently are. So still using version 1, when it is created, modified, how many files are in there, the total size of the data set. And we can scroll up and go here and get some really nice examples of how to consume this data set. We can explore it. So let's take a look at what is actually in this data set. So here we have the files, and here we see actually some Lego figures. And what we're going to do is to create a classifier that can tell us at which Lego Simpson or Lego figure it is actually looking at. So there are a lot of different classes, and from all the classes we have around 30 to 50 images. So these are the data sets. Under experiments, we keep track of all our runs. So every time we train our model, we can put the results in an experiment. So every time we run a training script, change some parameters, it will generate a new run under experiments. We have components. We can create and share our reusable components. We will see that at the later on at the end of the presentation. Also the same for pipelines. Under models, we can store the models our runs generate. So when we're happy with a model, we tested it a little bit, and we say, yeah, this model is good. We can say run register model, and the model will be saved under a name in model management. And the cool thing about model management is that you can connect to model management and say, hey, give me the Simpsons classification model version. Now we're here at 14, but we check out version 13. And then another one can pick out version 14. So it is kind of like if you program in C#, it's kind of like a NuGet repository. You pick out the model you want and use that in the software you build around it. Under endpoints, lift our published endpoints. So we have picked out the model, we have written the software, and we deployed it to like either a managed endpoint or to an Azure container instance. And here we can see all those different endpoints we can manage from here. Then we have compute. Under compute, we can have like 3 or 4 different types of compute. So we have compute instances. These are like single compute instances that mainly are used to run our Jupyter notebooks. We have compute clusters. These are our big clusters that can have a lot of GPUs, a lot of machines, where we can train our models on scale. These clusters can shut down, and scale up automatically based on how many jobs are in the queue. So this is my compute Optimus Prime, and we see that there are 6 nodes actually up and running. So I already spun those ones up because we all don't really want to wait that long. We don't want to wait like 10 minutes for my nodes and my cluster is scaled up. But I should definitely not forget to shut it down because this costs around 1.17 per hour. It's really good that they show that here and then multiply that by 6. So if I leave it on for 24 hours, it is quite expensive. So these machines are dedicated for me, and I can scale up automatically up to a maximum of 8 nodes. The maximum, and this is 1800 seconds before it automatically scales down. You can deploy this compute cluster in your own virtual networks. You can here see the individual nodes. So you can enable that you can use SSH to connect to these nodes to see what is going on, but I didn't do that. And here we see which runs are completed on this compute cluster. Data stores. Here we manage the connections to all our different data. You can connect to files on Azure Blob Storage, but you can also connect to Azure SQL, MySQL, and Azure Data Lake. And then we have a data labeling service, which I still have to check out, but it looked really cool. And we can link other services in Azure to Azure Machine Learning Studio. On the top, we have our notifications. We'll just tell that what is going on. And here we have some settings. We can actually go to dark mode here, change our languages, and have these app notifications here. So this is in very short Azure Machine Learning, the interface. So now what we're going to do is we're going to train a model. We're going to experiment and prototype with that model. And mostly we do that from a notebook. So here you see on my screen is a notebook that is running in my GitHub code spaces. So what I've done is I have a repository, I created a code space, and here we are. So if you go to this Azure Machine Learning PyTorch Visual Studio Code repository, I will share the link at the end of the presentation. you can just use this dev container to generate a code space for this environment. So I'm going into my directory prototyping, and here I have my notebook which I'm going to use to train my thing. So the cool thing now is I don't have to bother with all these Python versions and Onyx and all the things we're going to use on my machine. It is all in that GitHub code space. So if I have my other laptop, I can just connect to my code space and have exactly the same development experience. So I personally really like that. So let's start with running the first cell. And here we see all the dependencies. So to make this work, I've installed the Azure ML SDK. So I'm importing that, and the current version is 1.38. So the next thing is we need to connect to our workspace in the cloud so we can control it from this notebook. And for that, I'm using the CLI authentication. So let's see if I'm still logged in. Yes, I'm still logged in. So what you do is you use the command Azure ML or Azure AZ login, device code, you log in, and then you can use those credentials to connect to your workspace. So I'm connecting to my compute target, Optimus Prime, using my data store, the workspace blob, and then I'm connecting to my experiment called Simpson's PyTorch. So now we're going to do some remote training. So I'm connecting to the data set I already have in my workspace and we just looked at. I'm going to use a predefined image where my training is going to take place in. So you can train in two different ways. You can create your own environment, or you can use one of the curated environments we have. So for my job, I'm just going to use, I'm going to do a small classification project, actually as an example that you can directly find on the PyTorch website. So for me, the Azure Machine Learning PyTorch 1.10 on Ubuntu 18 with GPU enabled, is perfectly for the job I need to do. So I'm going to use that environment. And now you have to see it like now we have this, basically this container, and my training script is going to use that container. It's going to run in that container. I will show you a little bit later how it actually works. So now we have our data. We have the environment. So now we need to configure how this is all going to come together, how we are going to train it. So we are going to create a script run configuration. So the first thing we need is a training script. And that training script can be found, in my case, in scripts.train. So let's take a look at that training script. So this is my training script. I copied and pasted this from the PyTorch website and put it here, just to show you that you can basically run any code you want to train a model. So what do we do, and what did I add? Actually, what did I modify? I added some references to the Azure ML core, so I can communicate with my run, with the context where this job is running in. So I say run, get context. Then I enabled that it can parse incoming arguments, because that is what I want Azure Machine Learning to give me. So for instance, where is my data? How many apples? What is the learning rate? What is the momentum? And so on. Those are these things I want to have as variables. So I parse them here, and then I use them later on in my script. So here we prepare the data set, and here we start training the model. We go to the number of apples, and every time, and for every apple, I print the current accuracy and the loss, and I also log that to Azure Machine Learning. So later on I can connect, go to the experiment, go to the run, and see my metrics. And because these are floats, all logged under the same name, it automatically understands that it has to create a graph from it. Finally, I run the final accuracy, and then something you should not forget is that you actually have to save your model. So you say torch save, and you save it in the output folder. and everything you save in the outputs folder will be copied back to your experiment, to your run, so you can later access all those artifacts. So these are the main incoming arguments I'm parsing. So by using this command, Simpsons dataset, this is the dataset we have connected to. We say as named input, so now it is called Simpsons, and we mount it. So what it does here, now the image knows that it has to mount the data store of the data set as a directory in the container where my training script is going to run in. I tell my script that it needs to run on my Optimus Prime cluster. It has to use the environment, the PyTorch environment. These are the incoming arguments, and here are my training scripts. So everything in this directory will be copied to your environment. And let's do that and actually submit the script run configuration. So now we have the configuration, and we actually submit it to our experiment. And now we have a run ID here that generated. We also have a nice widget that you can run. So we can now actually follow what is going on with this model, or with this training, actually with this run. And it will stream back the outputs to me. Because I said run.log, you can follow it in real time. So now it is still scheduled. Sometimes you have to run the widget a few times. But here we see that it is already sending us some information. So it is now in the second April. Hey, seeing it is an array. And now it will start drawing this graph for me. So let's go back here to illustrate a little bit more what just all happened. So we have our local machine, my GitHub code space, or whatever environment you use. So you submit, when you say experiment submit this configuration, it snapshots the folder where you are, where your training script is in, and copies that over to the experiment. Then it is picking out that curated environment, or it is creating this new container for you, according to your specifications. It pulls it out, and it deploys that Docker image and your snapshot on your compute target. So in our case, Cybertron. Then it mounts your data store or your data set in your container. Then it launches your training script. And while your training script is running, it is sending out all the output and all the metrics back to your experiment. And because you have a widget that connects to your experiment, you can actually follow real time what is going on. When your training script is done, it copies over everything in the outputs folder back to your experiment. And then it will shut down your environment, your container, or your compute cluster. So if you didn't copy your data over, it is gone. So let's go back and hope that it is actually training. So it is completed because we have done like 10 rounds. So we see here that it is here 10. So this model is actually doing very, very well because it is a pretty simple model. So let's look at Azure Machine Learning, how it looks here. What do we have? So we go to the experiment. This is the last experiment we use. And this is the last run. You see, it is actually now. Oh. Okay, duration 4 seconds. Okay. 216. Yeah, it is it actually. So here we see how long it took. We see here which data set it's been using, which environment it has been using, the incoming arguments, the GitHub repository where the script was originated from. Here we see the metrics with all the accuracy and training loss and so on. It doesn't have child runs, and here in output we see what the script has done. In outputs we find actually the model. Here we see the different labels, and here is the actual PyTorch model. On the snapshot we see that it is copied over our training script, And here are some other tabs that are also new for me, especially this one. Oh, here we see how it actually used our compute and so on. So we can actually pick the best compute for this model. So that is all really cool. So we're very happy with the model, so let's register it. So now our Simpsons classification model is registered as version 15. So now if we go to models, we see it here, Simpsons classification. I tagged it with the conference name. We see here which run it is generated. From the run it is generated, we can go back to the data. And here we can actually look again which data was being used and read the log files. So now that we have the model there, we actually want to see if it works. So to do that in the easiest way is we pick up the model, create an environment, and deploy that environment to an Azure container instance. So for this, I'm not going to use a curated environment. I want to have an environment that I know exactly what is in. So I'm going to create an environment called Simpsons Inference, and I'm just going to add the packages I needed. Then I'm going to tell which script it has to use to do the scoring. I'm going to the score.script. And what the score script does, it has an init method and a run method. So the init method is run once, and it loads in the model and loads in the labels. And then the run runs the input data through the model, get the probability, and returns in JSON what the prediction is and what the score is of that prediction. So we're going to use that, and we're going to use an Azure container instance that has 2 cores and 4 GB of memory. So I'm going to run that, and then we're going to deploy this. We can do that from basically 3 lines of code. So we connect to the latest version of the model. So that is our version 15. Then we say Azure Container Service model, deploy it to our work and use this workspace, name it Simpsons classification test, use our model, use the inference config, that is the one with the scoring file, use the deployment config, that is how big and how powerful the Azure Container instance has to be. If it already exists, overwrite it, and now just show me the output while you are deploying it. Because I already deployed it and have the environment, it should take a maximum of, I was going to say 30 seconds, but it's going to be a bit longer. So I'll take a sip of drink, and while we are waiting, just now checking our status here. And hopefully it should say that it is deployed, because here we see it is used the existing image. If it is a new image, you want to add probably like 10 minutes to your deployment. You can see that's very easy. If you don't retrain your model, you can easily deploy it within 1 minute and 14 seconds. So now we can send an image to it and see if it actually gives us some result. Here we see it is now the time 0.6 seconds. It is Lisa Simpson, classifies Lisa. Lisa Simpson, 99% accuracy. So probably we want to do that with Bart. Let's hope Bart is also with the capital. You never know. So it can also classify Bart, Homer. It should all be able to classify those images. And yes, it is a real Homer. That was not in the training data set. This is actually in my separate test data set. So now we can start and optimize our model. It is already pretty good, but it can always be better. And for that, we can use a function called automated hyperparameter tuning. Because you saw I had all those different values I could tweak. So I can start doing that by hand, changing. Okay, try maybe 12 apples, or the learning rate. Do it like this. So I can do that over and over, and all the runs will be generated, and I can compare all the different outcomes of those training runs, but of course, I don't want to do that. So I can use this function, the hyperdrive, to do that for me. We can sample the data, like we can sample all those values, and then compare the outcome of the model. In this case, we're going to check if the accuracy is increased because we use a test set, so we can measure the accuracy, and then we can pick the best model for this problem without doing that much, except for a little bit of waiting. So how do we do that? It actually goes the same way as we've seen before, but we add like one extra layer. So we connect to the same dataset. We use the same environment, but now we say the parameters, and we do a random parameter sampling for a few of the arguments we are going to parse to our training script. Because in our training script here up, we could have all these different incoming parameters, like the momentum and the learning rate and the number of epochs. So we're going to sample them. So we say choose random values between 3 and 5, the uniform here between that, and so on. And then we only parse where it can find the same data set. We have exactly the same script run configuration, but we're going to wrap this script run config into an hyperdrive config. So here we say we give the hyperdrive the parameters it has to sample. We tell it which metric it has to watch, so the final accuracy, and then we say what our goal is. We want to maximize that. So we can have some early termination policies also in place, but we're not diving into that now. And we say, I will actually start running it because we want to see the outcome of it. We say maximum of 4 runs. So probably you want to have that like 16. And then we say how much of these runs can we run next to each other. So remember, for every run, my cluster have to add a node. So this doesn't overrule your node count on your cluster. So if your cluster is limited to 8 concurrent runs or 8 concurrent nodes, it will not go beyond that because you specified it here, luckily. So it is using this, and also you can use the hyperdrive run widget, the widget to show the hyperdrive run. Here we see it is running. Don't know what it's doing now. This widget sometimes doesn't really update, but we can see here a link to actually see that in Azure Machine Learning Studio. So here we see it is running. We can go. Here on the child runs, we see that no child run is actually started. But there we go. The 4 child runs are scheduled, and here we see which parameters that is actually sampled for us. That's handy. So these ones should be starting soon. But in the meantime, to save some time, we can better go to another hyperdrive. Pipeline, experiments. Let me find a previous one. It is running. Oh, yeah, the hyperdrive. I ran it like an hour ago just to check if it was working. So here on the child runs, now we see the different outcomes. So it plots it nicely for us here in the graph. So we see that the number of epochs was for everyone 4. But then if you learn the learning rate and momentum adjusted, we see what's lead to which accuracy. So here we see that the run with Happy Carrot, called Happy Carrot, was the best run in this case. So these are the parameters we can actually use. So let us see if this is already doing something. Yeah. So this is our run. We see that they all are completed. And here we see that number 1 was the winner with a low momentum and high learning rate. They led us to an accuracy of 0.98. So that's pretty cool. So we have that now here. So now we know we kind of experimented with it, because this is like how we figured out which model to use, which kind of parameters to use, but now we want to productionalize this. And how can we do that? Because now you see kind of the training code is wrapped in a Jupyter notebook. It is really nice for experimenting, but probably not the best way to get this into a pipeline or into a continuous integration process. So for that, we can use something like the Azure CLI Machine Learning vNext extension. So this extension kind of separates those two. So we use YAML files to actually create our configuration, how our scripts have to run. So now we have that in YAML, and we have our training code. We can actually use these command lines comments into a continuous integration thing like GitHub Actions or in Azure DevOps. So let me show you how you can create a pipeline using the Azure CLI and productionalize what we just saw, this script, how we can run that in a pipeline. So let's have a look. So this is a YAML file, and this specifies a pipeline. What the pipeline is going to do, it's going to train the model like we have done before, but then register that model for us. Then spins up another job to convert our PyTorch model to an Onyx model and also register the Onyx model. Very simple or very default common pipeline. So what do we see here? So instead of having that configuration on which compute cluster it has to run, which workspace it has to use, which training data it has to use, in Python, we have those things here and just the training scripts in Python. The cool thing is if you have the Azure Machine Learning, oh my God, there are a lot of subscriptions, the Azure Machine Learning pipeline installed. No, we're not going to reload it. You can actually see that. So there is a Azure Machine Learning Visual Studio Code plugin, which you can install in Visual Studio Code, and you will get the same items as you see here in Visual Studio Code, which will have autocomplete here, which it also have if this doesn't load. So what we can do now is say we use this training data, because this is the data we also used in there. So let's use that and save it. But what we see here is that we're using all type of components. And these components you see here. So the register, the train, and the convert component. So now, because I registered two models, I can use the same component to actually do that and just use some different parameters as an input. But let's have a look at the training part, because that is the same as what we did in the previous step. So we say train model, train the classification model. This is version 1 of my component. We have some inputs where the training data is, the APOS and the learning rate and momentum, exactly the same as there. But now we specify here on which environment it has to be used. It should also autocomplete that. Yeah, so we see we can pick from the curated environments, and it even shows my own environments here. So we're still going for the same image, and this is just the command that it has to execute. It's the same for convert to Onyx, onyx.py. We see that here, onyx.py. And these are then the training scripts. So you can test this individually. The good thing that it is now the configuration and actual training code is being separated. So let's run this pipeline. See, it is just running the command for me here. And it has hopefully accepted it. So now we can go back here to the pipelines tab, and we should see our Azure Machine Learning pipeline appearing here soon. So in the meantime, while we wait for it, we can go to the previous pipeline I've run. And the really nice thing is what it does, it kind of visualizes it for me. So here I have my Lego 1, my Lego version 1, dataset input, the training. Here we see exactly the same as what we were seeing when I was doing it with the Python SDK. My input parameter, the outputs, my same kind of metrics, my output log, so I can actually read everything the script is doing. We see that after that, it splits in two. It's register my model, and it starts converting it to Onyx, and then finally it will register it as an Onyx file, as a model, Onyx model for me in Azure Machine Learning. So let's see what it is doing here. Didn't really submit it. Did it really submit it? Created by Henk. Oh, I submitted not the pipeline. No. It was the component only. You have to submit a pipeline. So here we see the pipeline. We see here the inputs. We give it the training data, and then we save the train output, and then we can use the output in the next steps from all the models. So jobs, the train model step, use the outputs, use the training output. We can parse the output between different steps. So that is really cool. So the job is now submitting, and we should be able to now actually see it here under pipelines. Here we see it is running, and it is now starting with our training job. Running, let's see if it had already, yeah, it is done one round. So this is running and will deliver us a model soon, which is will register afterwards and convert it to Onyx. So this is really cool, and definitely the way you should use Azure Machine Learning. Separate your configuration with your training code if going to production. So next, managed endpoints, or online managed endpoints. And these ones are super cool. You saw me deploying it to an Azure container instance, saying override. Then, you, of course, while you overwrite it, your container goes down. So that is not really suitable for a production scenario. But online managed endpoints are suitable for production when it goes from preview into general availability. So what do those things do? So you have one endpoint, and in one endpoint, you can have multiple deployments. And every deployment is individually scalable. Those deployments can all have different compute under them, different model, different configuration. And your endpoint can direct traffic to these different types of deployments. So this is really handy if you have a new version of a model and you want to see, for instance, on which computer it runs best. Or you want to see and compare the metrics, like the accuracy of your models. So you can say 90% goes to my proven model, and we pick 10% and we send it to the new model and just see what happens. But for me, I want to see which of my model is actually the best. Is it the Onyx model? Is the Onyx model faster? Or is my PyTorch model faster? So what I've done is I've deployed my Onyx model and my PyTorch model into one endpoint and routed 50 or 50% to one of those deployments. So we can find that deployment under endpoints. We can go to the managed endpoint. Here we see it is a container instance, or here it is managed. Click here, and we see we have two deployments here. We have the Onyx and the PyTorch. 50% of the traffic, 50% of the traffic. We can see the deployment logs. We can view metrics here. So let's load. We can actually go to the overview. Here we see like how much the CPUs and what is all here going on. So it's basically all our statistics. We can test them. Here is a script on how to actually consume it in all different languages. We have some monitoring actually built into Azure Machine Learning. And here we can read the deployment logs. So I can test this from my code space. I'm just doing a simple post to my endpoint using my token, because it is by default secured with a token. And then I will send my BART image to the endpoint. So I'm sending it, and here we see it goes through Azure ML front door. We run it, and here it is hitting our Onyx version 2 deployment, and here we see the accuracy. So we do that again, and now we see it is hitting the PyTorch one. We do it again, see it is hitting the Onyx one. So we do that a few times, and here we see it actually change. So that is really cool and definitely new and a really handy way of deploying and managing your models. So that kind of wraps it up. Managed, then we kind of wrapped it up with managed endpoints. So let me have a look if there are questions in the chat. So this would actually be the moment to ask me any questions about managed endpoints or Azure Machine Learning. I know there is a little bit delay, so I will wait a little bit if any questions come in. But if you want to try this on your own machine, or using GitHub Codespaces or Visual Studio Code, or a regular Jupyter notebook, you can go to github.com/henky/Azure Machine Learning PyTorch VS Code. Clone the repository and train this exact model using pipelines and the Jupyter notebook to prototype. You can find me on Twitter. You can always reach out to me if you have any questions. All code and other code is available on GitHub, and more information about blogs, or if you want to meet me in person, then you can find where I am the coming months. So with that, I don't see any questions coming in. With that, I want to thank you for your attention, and I hope you enjoy the rest of the conference.